Good morning everyone. So we are starting on a new chapter, that is square roots and cube roots. So already you know the square numbers we have learned in exponents and powers. So what are the square numbers? We know that square numbers are to multiply one square. One square is nothing but multiplying one in two times. And multiplying one how many times? It is two times. So 1 into 1 will be equals to 1. In the same way, 2 square will be equals to 2. We are multiplying two times. That will be 2 into 2 will be equals to 4. 3 square will be how much? 3 into 3 is equals to 9. And 4 square will be 4 into 4 will be 16. 5 square. 5 we are multiplying two times. That is 5 into 5 is equals to 25. 6 square. 6 square is 6 into 6 is equals to 36. 7 square is 7 into 7 is equals to 49. The same way, 8 square will be 64. 8 into 8 is equals to 64. 9 square will be 9 into 9 is equals to 81. And 10 square will be 10 into 10 is equals to 100. So these all are square numbers. So which numbers we will call it as perfect squares here? 1, 4, 9, 16, 25, 36, this 49, 64, 81 and 100 and so on. So many perfect square numbers are there, but I wrote the 10 square only here. So these set of numbers we will call it as perfect squares. What do you mean by perfect square? Perfect square is nothing but which can be expressed as product of two equal factors. Every number here, every number is having equal factors, that is 5 and 7. We are multiplying two equal factors here. So after multiplying two equal factors, you are getting one perfect square. So what do you mean by perfect square? In a perfect square is a number which can be expressed as product of two equal factors. We will call it as perfect square. So these are all numbers 1, 4, 9, 16, 25, 36, 49, 64, 81, 100 and so on. We will call it as perfect square numbers. So for finding this perfect squares, we are having some properties. So what are the properties we will see now? Properties of perfect square. So what is the first property? In this all numbers, always the units place are repeated. So which values are repeated? 1 is repeated here and here, and 4. In a 2 square also units place is 4, and 8 square also units place is 4. In the same way 9. 3 square is 9. In the same way here 7 square is units place is 9. So in the same way here 16 units place is 6. 4 square is 16, units place is 6. In the same way here 6 square, that is 6 into 6 will be 36, units place is also 6. Only the 4 different type of numbers are repeated here. What are that? 0, 1, 4, 9, 5 and 6. Only these numbers will be repeated in the perfect square. So what is the what is the property of first square? The square number can only end with the digits. The square number can only end with the digits. Which numbers are ending here? 0, 1, next is 4, 5, 6 and 9. Only these 6 different type of numbers are repeated in this square numbers. Remaining, that means that square numbers will be having the unique digits with these numbers only. The remaining numbers, what are the remaining numbers here? 2 is not there in this set. 3 is not there. In the same way 7 is not there, 9 is not there, 8 is not there. So the numbers which are having the unit digits as these, if you are seeing the unit digits as 2, 3, 7 and 8, they will not be a perfect squares. Always the perfect squares will have the units place will be only 0, 1, 4, 5, 6 and 9. Because in this set we are seeing only these 6 different type of digits. So the numbers which are ending with these 4 digits, they will never be a perfect squares. So this is the first property. What is the property? The square number can only end with the digits 0, 1, 4, 5, 6 and 9. So this is the first property. Next property is number of zeros at the end of at the end of perfect square will be even. That means for perfect square number only you will be seeing even number of zeros. Suppose 100. How many zeros are there? 2 zeros are there. Here 100 is a perfect square because you can write it as 10 into 10. So equal factors, product of two equal factors is called as perfect square. So 100 we can call it as perfect square. In the same way 2500. So 2500 is also a perfect square. What is the second property? Number of zeros at the end of a perfect square will be even. If you are seeing the even digit of zeros, it may be a perfect square. Suppose you are taking any other numbers. 700. 700 is not a perfect square. What I am telling, if you are seeing the even digits of zeros, it may be a perfect square. So next is, so what is the first property? First property is the square number can only end with the digits 0, 1, 4, 5, 6 and 9. If you are seeing the digit units placed with these digits, it may be a perfect square. And if you are having 2, 3, 7, 8, the number which are ending with these 4 digits, it will never be a perfect square. You have to remember that. Next one is the number of zeros at the end of perfect square will be even. If a number having even number of zeros, so it may be a perfect square. So next property is the square of even number. The square of even number will be again a even number. So what is the next property? The square of even number will be always even. Suppose you can take 2 square here. What is 2 square? I am squaring this 2. That is 2 square is 2. We can write as 2 into 2. So 2 into 2 is how much? 4. So square of this 2 even number. 2 is a even number. So square of even number, again the result will be even itself. In the same way 4 square. Square of even number. 4 is an even number. So this 4 we are multiplying how many times? 2 times we are multiplying. 4 into 4 is how much? 16. So square of even number is always even. In the same way you can see in this set. Square of even number is again a even number. 6 is also even number. 36 is also a even number. Square of even number. 8 is a even number. So the result is also an even number, that is 64. In the same way here 10 square. 10 is an even number. So if you multiply 10 2 times, the result is how much? 100. So 10 is also even number. 100 is also even number. So what is the third property here? The square of even number will be always a even number. Next is fourth property. The square of odd number will be again a odd number. So if you are taking a square of any odd number, so 3 square, 3 is a odd number. So square of odd number, 3 how many times you have to multiply? 2 times you have to multiply. So 3 into 3 is equals to 9. So square of odd number is again a odd number. So in the same way you can see in this set, 1 is a odd number, square of 1 is again 1. 1 is also an odd number, 1 is also an odd number. So 3 square is equals to 9. So 3 is an odd number, 9 is also an odd number. Here 5 is odd number, square of 5. The result is how much? 25. So what is the next property? If the number has 1 or 9 at its units place. If you are having any units place, suppose I am taking here 19. What is the units place here? 9. So if you are having the number has 1 or 9 at its units place, or you can take 11 here. So what is the units place value? 9 and here 1. So if you are having the units place as 9 and 1, always the square of that value, the units place will be again 1 itself. So 11 into 11 will be 121. So what is the units place value? 1. In the same way 19 into 19. So multiply 19 into 19. So it will be 361. So what is the units place value again? 1. So what is the property here? If the number has 1 and 9 at its units place. If you are seeing the units place with 1 and 9, always if you do the square of that term, the units place will be again 1 only. So 19 square will be 361. The units place is 1. In the same way, 11 square is 121. Again the units place is 1. So what is the property? The number, if the number has 1 and 9 at its units place, its square ends with 1. In the same way, if you take the other value here, you can observe here. So if it is having 1, the units place will be 1. In the same way, if you are having 9 square, the units place will be 1. Like that, how many different numbers are repeating here? 4. That means if your number has 2 or 8 as a units place, if the number is having 2 or 8 its units place, always the square number will end with 4 here. So in the same way, we will take one example. So what is here? The number has 2 or 8 at its units place. If your units place is 2 or 8, always the square number ends with which number? See here, 4 and 4. 64 units place is 4. So it will be ending with 4. So you take one example. I am taking it as 12 and also I am taking it as 18. So what is the units place? So units place of 12 is 2 and units place of 18 is 8. So 12 square is how much? 12 square is 144. So what is the last digit of 12 square? That is 4. That means it is ending with 4. In the same way, 18. So what is 18 into 18? That is 324. So 18 square is how much? 324. So 18 square is also ending with which digit? That is 4 digits. So what is the next property? If the number has 2 or 8 at its units place, its square ends with which digit? That is 4 digits. So 2 square is 4 and also 8 square is 64. If you are having the units digits as 2 and 4, always the number, the square of the number ends with 4 itself. Next coming to, now this is completed, this is completed. Now what are the remaining values? Here 9 is there. Where is another unit? Is it 9? Here. So if the numbers are ending with the number has 3 and 7 in its units place, always the square number will ends with 9. So what is that? If a number having the units place as 3 and 7, always the number ends with 9 here. So we take one example. So what are the digits? 3 and 7. So 3 square. So if you are taking the number has 3 and 7 at its units place. If you are taking any number, I am taking it as 13. Next, I am taking it as 17. So 13 square. 13 square is how much? 169 and 17 square will be 270. 9 numbers. So 13 square, the units place is 3. 3 square is 9. So 13 square will be 169. Always it will end with 9. In the same way, 17 square. 7 square is 49. 49 units place is 9. So in the same way, 17 square is 289. It is ending with the digit 9 here. So this is the properties. These are the properties of a perfect square. Next is Pythagorean triplet. What do you mean by Pythagorean triplet? So what do you mean by Pythagorean triplet? So in Pythagorean triplet you will be having 3 integers, 3 different type of integers. So when this Pythagorean triplet will be satisfied, we will see. So what is that? This condition should be satisfied. What is that? A square plus b square should be equals to c square. So if you the square of these two terms, the square of sum of these two terms, if you add a square plus b square, the result should be equals to c square. So whenever this condition is satisfied, the Pythagorean triplet will be satisfied. So what I told here, a, b, c are integers. Suppose I am taking a value as 3, b value as 4 and c value as 5. So what we have to do, we have to substitute this a value, b value and c value in this condition. What is condition? A square. A square is nothing but 3 square plus b square is nothing but 4 square is equals to c square is nothing but 5 square. What is that? 3 square is 9 plus 4 square is 16 is equals to 5 square is 25. 9 plus 16 will be 25 is equals to 25. So LHS part is equals to RHS part. So whenever these two LHS and RHS parts are equal, then we can tell that this 3, 4, 5 is in the form of Pythagorean triplet. So you can take one more example. So A value I am taking it as 2, B value I am taking it as 4, C value I am taking it as 5. So what is the A value? 2 square plus B value is 4 square, C value is 5 square. 4 square is how much? 2 square is 4, 4 square is 16, 5 square is 25. So 4 plus 16 is 20 and here you got it as 25. So 20 is not equals to 25. So what we can say here, 2, 4, 5 are not Pythagorean triplet because this condition is not satisfied. So what is the condition here? A square plus b square is equals to c square. So the square of the sum of the squares of these two terms should be equals to c square. So whenever this condition is satisfied, the given numbers will be equals to, they will satisfy this Pythagorean triplet. So one more example we will take here. That is A is equals to 6, B is equals to 8, C is equals to 10. So with these values I am substituting in this. What is that? A square is nothing but 6 square plus B square is nothing but 8 square is equals to C square is nothing but 10 square. So what is this? 6 square is 36 plus 8 square is 64 is equals to 10 square is 100. 36 plus 64 is 100 is equals to 100. So you got LHS value is equals to RHS. So therefore you can tell 6, 8, 10 are in the form of Pythagorean triplet. So whenever this LHS part and RHS part, whenever this condition is satisfied with the given numbers, then only the Pythagorean triplet will be satisfied. So here A, B, C are integers. So remaining topics we will continue